Hello everyone, welcome to today's class. In this lecture we are going to discuss solution of linear differential equations. Okay. So for solving differential equation, first method was separating variable. Now we are doing linear differential equations. So the format goes like this: dy by dx plus py is equal to q. Okay. Here p and q are functions of x. Okay, there are some functions of x, we don't know. Okay. Now in order to solve, if the equation is in this form, dy by dx plus py is equal to q, there is a way to solve it. The first step I'll say is calculating an integrating factor, if. Okay, so integrating factor. So integrating factor is e raised to power integration p dx. Why dx? Because p is a function of x. Okay, and solution that we are supposed to find is in this form: y into if, integrating factor, is equal to integration of q into if. Since q and if will also be a function of x, so dx. Okay, so these are the key points that you should know. Okay. Another way this can be written is, instead of y and x, we can replace this. Okay, y will be replaced by x and x will be replaced by y. Okay, so the other form is dx by dy plus px is equal to q. We are just interchanging x and y. Okay, so every thing will be pretty much same, just will change x and y. Again, same thing, p and q are functions of x. Okay. And your integrating factor is still e raised to power p, integration of p, but instead of dx now you have dy, because they are functions of y. We are changing x and y now. And last thing, solution is in the form x into if is equal to integration of q into if plus c, of course. All right, let's look at some questions now. We'll start with a very basic question, then we'll increase the level bit by bit. Find the general solution of this equation. Clearly you can see dy by dx plus py is equal to q. Okay, what is our p? First thing is identify p and q. P is -1 and q is cos x. Okay, I told you that p and q are function of x. You'll say that there is no x present here, but yes, this can be rewritten as -1 into x raised to power 0. So constant is okay. Okay, they can be in form of any variable. Okay. Next is finding if. First of all, always find if. If is integration e raised to power p dx. So e raised to power minus 1 integration dx. So e raised to power, what is the integration of minus 1? Minus x. Okay. And don't write plus c in integrating factor. Okay. Next part comes the solution. Okay, we have compared it. Solution is in the form of y into if is equal to integration q into if and dx. So y into e raised to power minus x is equal to q is cos x into e raised to power minus x dx. Okay, so now you have to integrate e raised to power minus x cos x. How will you do that? Most of the questions are done actually by using by parts. Okay, so let's do by parts, because two different kinds of functions is there. Let's call this as I. Let's solve for I first. I is equal to integration e raised to power minus x cos x dx. Okay, I late. Okay, inverse is not there, log is not there, trigo is there. Call this as first function, call this as second function. Okay, algebra is not there, exponential is the last one. So by parts, so first function as it is, integration of second function, that's e raised to power minus x upon minus 1. So basically minus e raised to power x, no? Because this. So I've already integrated it, that's why this is negative. Minus integration of this second function, that was minus e raised to power minus x, and differentiation of this, differentiation of cos is minus sign. Okay, so negative negative cancels. Okay, so this is minus e raised to power x cos x minus integration of, now again we have to do by parts on this also. So again same thing, first function, second function, so by parts on this. So you'll get sin x, integration of e raised to power minus x, again minus e raised to power x. Okay, minus integration of e raised to negative of e raised to power minus x, differentiation of sin x is cos x. All right, so I then copy this minus e raised to power x cos x, change the sign. Okay, multiply this negative, so this is become negative negative positive e raised to power minus x. It was minus x, it was minus x, sin x, and this will negative negative will cancel, and negative outside will make it this another negative, integration e raised to power minus x cos x. This is again same as the question I. Okay. Okay, this was already done in by parts. I solved the same question in the by parts lecture. Take this on the left side, so I plus I becomes 2i is equal to e raised to power minus x, you can take common, this will be sin x minus cos x. Okay, and plus c, of course we are doing by parts, so final answer will have also c. So I is e raised to power minus x sin x minus cos x, again plus c by 2 or c, same thing, call this as c1, then c1 by 2 is another constant c. Okay, this is the result, so let's put it here. Y into e raised to power x, y into e raised to power minus x. So the solution is basically y into e raised to power minus x is equal to integration we have already done, e raised to power minus x by 2 sin x minus cos x plus c. Okay. Most of the time we'll try to give answer as y is equal to something. Okay, so if we give the answer of this question also in terms of y. So take this e raised to power minus x on the other side. Okay. So you get y is equal to take this whole term on the other side, and don't sit directly cancelling e raised to power x with e raised to power minus x like this. The reason is because c is also present. So this will be e raised to power minus x sin x minus cos x by 2 upon e raised to power minus x plus c upon e raised to power minus x. So this cancels it. So basically y is sin x minus cos x upon 2 plus, you take this in the numerator, c into e raised to power x. That's your answer. So we got the solution of the differential equation. Yes, the questions are slightly lengthy sometimes because of the by parts. Okay. But this if part, sometimes the questions are just regarding finding the if, so you should be clear with this. Okay. All right, let's do another one. Same thing, we are finding general equations. All right, this time if you look at the format says we should have dy by dx alone, but there is x present here, plus py is equal to q. So what do? We divide both sides by dividing both side by x. Okay. So your equation will look like this now: dy by dx plus 2y by x is equal to x squared divided by x is x. Now coefficient of your y is your p, and this is q. Okay. So let's calculate if now. if is equal to e raised to power integration p dx. Okay. Integration 2 by x dx. What is the integration of 1 by x? Basically log. So this is 2 log x. Okay, forget about the mod for the time being. Okay, and don't write c. Okay, now what do? We know one property na, that e and log can cancel each other. Take this in the power. What do you get? E raised to power log x square. E and log cancels. What do we get? X square. Okay, so your if is only x square, and I think after that it is very easy. Now let's write the solution part. Solution is y into if is x square is equal to integration of q, that is x into x square dx. So y into x square, what is the integration of x? This is x cube, so integration is x raised to power 4 by 4 plus c. Okay, take this x on the other side. So usually we have the tendency to write our answer as y is equal to something. So y is equal to, this will become x square by 4 plus c by x square, or c x raised to power minus 2. Any way you can write, that's your answer. Okay, so remember that e raised to power log you can cancel, but log has to be alone. So take these two in the power of x. We use the same concept in differentiation as well as in integration also. There were questions on this property. All right, and these kinds of questions are quick. Okay. Usually if you ask what's the preferred choice to solve any differential equation, the easiest one or the most preferred one is linear, but the question has to be given in the form of linear equation. Okay, so if you have to choose between between a linear differential equation, or you are given choice between, let's say, a homogeneous one. Okay, homogeneous, we'll see. Homogeneous is the most lengthy typical problem. Okay, sometimes they are short, but not short like this. You cannot solve that in like this much portion of the screen. No. All right, and they are also very lengthy. Integration point of view, they are also very tough. Okay, this was a very simple integration. Let's see this question. The problem with this question is right now the equation is not in the form of dy by dx anyway, so we have to create dy by dx. Let's create dy by dx. Take this on the other side, so you'll get x y dx is equal to x plus 2y square dy. Let's generate dy by dx. So dy by dx, take what you do is take this here, take this whole thing there. So y upon x plus 2y square is equal to dy by dx. Now is there any way you can think of this like compare it with like dy by dx? The form is dy by dx plus py is equal to q. Is there any way you can get y on the left side? Can we take this y on the right side? Can we do that? No, because of the denominator. Okay, so this is not a linear differential equation, first of all. So what do we do? Whenever you get stuck with dy by dx, try dx by dy. Usually that happens. Okay, if dy by dx is not working, go for dx by dy. Let's do the reverse now. This time y dx is equal to x plus 2y square dy. Take dy here, take y here. So dx by dy is equal to x plus 2y square upon y. You'll say it's the same problem all over again. Still we cannot get x, but wait. If I do this, dx by dy is equal to x by y plus this is 2y. If I split this in two parts and get this on the left side, dx by dy minus x by y is equal to 2y. Now can you see this as a linear differential equation? This is dx by dy minus px, or plus as such, it's plus always, plus px is equal to q. Yeah, and now you can easily identify what's your p, what's your q. Okay, so my p is minus 1 by y. Now p and q will be function of y, just interchange x and y, and q is 2y. So let's calculate now if. So this will be e raised to power minus integration 1 by y dy. Okay, so integration is e raised to power minus log x, sorry, log y, because it's going in terms of y. Take this negative 1 in the power, so you get e raised to power log y raised to power minus 1. So e and log can cancel, so this is y raised to power minus 1 means 1 by y. That's your if. Now let's calculate the solution. Solution is in the form of x into if. So x into 1 by y, then let's write down x into if is equal to q into if. So this is x into if is 1 by y, integration q is what is q? 2y into 1 by y. Oh my god. They cancel it. All we have to do is integrate 2. What is the integration of 2? This time 2y. Okay, plus c of course, and take this y on the other side, you get x is equal to 2y square plus cy. Okay, that's the solution. Okay, all right, next one. Now it's not like trigo can't be involved in this. Here you go, you have the trigo. And this is given in dx by dy plus y cot x again. And right, so far what we have done, we have seen the equation has only 3 terms. This has 1, 2, 3, 4 terms. So always write the format and then try to think dx by dy plus px is equal to q. We need term of x on the left. X, this is x, only x, not x square. But there is x square also, na? 1 second. All right. There's a problem with this question. There's a misprint in this. Change this question. Change this to dy by dx. Okay. Otherwise, that will not be a linear differential equation. Okay. So this is dy by dx. Okay. So dy by dx plus py is equal to q, and p and q are functions of x, so they are okay. Clearly this is our p, this is our q. Okay, so p is cot x, q is 2x plus x square. Now let's do if e raised to power integration p dx. So what is integration of e raised to power what is integration of cot x basically? Okay. Integration of cot x is log sin x, and e and log cancel, so you have sin x as your if. Now let's talk about solution. Solution will be y into if, that's sin x, is equal to integration of q, which is 2x plus x square, into if is sin x dx. Okay, lengthy. Why it's lengthy? Why I know this lengthy? Because algebra and trigo combined in multiplication. So this is by parts. Okay, so let's do by parts. Is there still, oh, this is not x square, this is x cot x. Oh, so this is, there is an x square cot x, I think. Let me check whether that cot x is being multiplied with both the terms or just that. No, it's with the x square only. Okay. So fine, I'll change this also like this. Okay, this is x square cot x. I'll have to change. There's a lot of misprint in this question. Cot x into sin x dx. Okay, so it's not by parts as simply. So what we have to do, we have to multiply this first of all. Let's multiply. This is 2x sin x plus x square cos by sine into sine, that is cos x dx. Okay, so we have to do these two integration. Okay, let's apply by parts. What else we can do? Let's apply by parts. Let's solve the first one and then we'll solve the second one. Consider this as your first function. Okay, consider this as your second function, isolate. Okay, now let's integrate. So first function as it is, sin x as it is, integration of 2x is x square minus integration of this x square, and differentiation of sin x is cos x. And look at that, what happened. Okay, so integration of x square cos x. So what happens is we don't have to integrate this now, they cancels. So plus c, of course. Okay, so we got ourselves y sin x like this. So y sin x is equal to x square sin x plus c. So sin x will cancel, but take it on the other side. So x square plus c by sin x plus c. You can write x, or you can write x square plus c cosec x. All right. Okay, additional information. The question says we have to find the particular solution. It's given in the question that y is 0 when x is pi by 2. So let's use this condition. So we know that y is 0 when x is pi by 2. So put this in the equation. Y is 0, so 0. X is pi by 2, so pi square by 4 plus c by pi by 2 is, sine pi by 2 is 1. So we get c as minus pi square by 4. So final solution, y is equal to x square minus pi by 4 sine x. Sorry, minus pi square by 4 sine x. That's the answer. All right. Next question. This time we have to find the equation of a curve. Okay, so same thing basically we have to find the equation or solution basically passing through 0 comma 1. That means this is the value of x, this is the value of y. If the slope of tangent, I think this is what we have done in separating variable also, slope of tangent is dy by dx. Okay, to a curve at any point is equal to the sum of x coordinate, means he is saying that dy by dx is equal to sum of x coordinate plus and the product of x coordinate, y coordinate, x plus xy basically. It's saying like this. Okay, so we can take this xy on the other side. This becomes dy by dx minus xy is equal to x. What you can see, this is a linear differential equation, dy by dx plus py is equal to q. So this is our p, this is our q. So let's calculate IF now. E raised to power minus integration of x dx. So that's e raised to power minus x square by 2. Alright, then solution comes like this. Solution goes with y into if minus x square by 2 plus integration of q, that is x into e raised to power minus x square by 2 dx. Now don't do by parts. Why? X square by 2 is present. Use this. What is the difference? If you take this, let x square by 2 is t, then x dx is dt. You see x dx. So this integration becomes integration basically e raised to power minus t dt. What is the integration of e raised to power minus t? That's minus e raised to power minus t, or in a way we can say e raised to power minus x square by 2 with a negative sign and plus c, of course. So we have done the integration. So final answer, y into e raised to power minus x square by 2 is equal to minus e raised to power minus x square by 2 plus c. If we take this e raised to power minus x square by 2 on the other side, it becomes y is equal to minus 1 plus c upon e raised to power minus x square by 2. Okay, or you can write this in the numerator, minus 1 plus c into e raised to power x square by 2. That's your general solution. The point was given 0 comma 1. That means if this is a curve and it is passing through 0 comma 1, this is the value of x, this is the value of y. Let's put in this equation. Y is 1, minus 1 plus c into e raised to power 0 is 1. Anything raised to power 0 is 1. So we get c value as 2. Now again your solution is, this is general solution, this is particular solution. Finally, after writing the value of c, we write particular solution. So that's y is equal to minus 1. Okay. Minus 1 plus 2 into e raised to power minus x square by 2, not minus x square by 2. Okay. All right, so we are done with these kinds of questions. Now let me show you few others that are regarding slight variations. Look. Okay, look at this question. Do you see this as a linear differential equation? No, because dy by dx plus py is not there. Also, if you suppose try to separate this, you can take this x plus y from multiplication to division here, but still you cannot separate x and y. So separating will also not work. Was also not working right now. If you check homogeneous also, this will look like not even homogeneous also. So if dy by dx is not working, what is the first thing that I told you to check? Check for dx by dy. So take this on the other side, it becomes x plus y is equal to dx by dy. Do the reciprocal, and now you rewrite this as dx by dy. Take this x on this side, minus x is equal to y, and now you got yourself a linear differential equation with dx by dy minus px or plus px is equal to q. Okay, this is your p, this is your q. Let's calculate your if. So if is e raised to power this time minus 1 integration, and but this is with respect to your dy, because we are doing for dx by dy, otherwise it will be e raised to power p dx. Okay, so this is e raised to power minus x, sorry, bad habit, minus y. All right, then solution is not x, y, x into if e raised to power minus y is equal to integration q y into e raised to power minus y dy. This we have to do it by parts, because this is substitution cannot work here. Okay, if only it was y square, we could have used the substitution. So I let first function, second function, let's apply. X into e raised to power minus y is equal to first function as it is, integration of e raised to power minus y, that's minus e raised to power y, minus integration of same thing but we have written here, minus e raised to power minus y, differentiation of y is 1 dy. So this becomes x e raised to power minus y is equal to y into minus y into e raised to power minus y minus plus integration of e raised to power minus y is again negative, so that becomes effectively e raised to power negative, so we have written e raised to power minus y plus c. All right. Cancel like this, otherwise it will create confusion. Let's see. Now we have to generate x this time. Okay, try to generate, take this e raised to power minus y on the other side, so you'll get x is equal to minus y. If we divide this by e raised to power minus y, this will become minus 1 plus c upon e raised to power minus y, so make it reciprocal, minus 1 minus y minus 1 plus c e raised to power y is equal to x. Okay, that's your 10th question. All right. Okay, we're done with this. Another example of this sort. Let's check the next one also. Let's see. So this time again equation is not directly given, so you have to create your dy by dx. Let's create dy by dx. So y dx is equal to, take this on the other side, that becomes make this negative, so y square minus x dy basically. Okay, then sorry, dy, then generate dy by dx. So again y upon y square minus x is dy by dx. Same idea, you cannot generate dy by dx is equal to py plus q. So what do? This is not generating anything, you do reciprocal of it, both sides. Y square minus x upon y is equal to dx by dy. Now if we separate this, because this is not linear differential equation, but if we arrange this, this becomes y is equal to y minus x by y is equal to dx by dy. Take this on the other side, so you'll get dx by dy plus 1 by y x, or plus x by y is equal to y. Now this is linear differential equation. Okay. That's your P. This is your Q. Calculate your IF, e raised to power integration P dx, sorry, dy, e raised to power integration 1 by y, that's e raised to power log y, e and log cancel, y only. Solution x into if y is equal to integration of y into q into if is also y dy. So basically xy is equal to y square integration is y cube by 3 plus c. If you want, you can take y on the other side also, but this is looking like a good equation, good way to represent an equation. Yeah, all right. Okay, we are done with this linear differential equation now. That's it for this lecture. Class is over. See you in the next class. Good day, everyone. Bye.